Maybe I'll leave like within 10 questions, less than 10 questions for each.
Exactly, because at the beginning of the semester, one homework is just 10 questions, and a lot of homeworks we've done so far have like 15 questions, and like it's.
Right. I see. Okay, I'll try to leave less.
No, I totally get where you're coming from. Cause like I totally get where you're coming from. Cause I mean, I personally didn't have a problem with it, but like, yeah, I mean, there was like a lot of questions on some of your homeworks. So like, yeah, definitely.
Yeah, that's not good enough. Like, we got other classes and we're trying to do stuff, and like, it's just what I feel, basically.
Okay, I'll try to leave less questions. All right. Okay, so any other questions? Anyone want to present some questions? Yeah, I see homework 17 is a lot. 10, like 15 of them.
I think Jeremy wanted to present, if I'm not mistaken. Yeah, like in the beginning, you said you wanted. Yeah, I'll do that.
I'm trying to see from the chat to see who wants to present. Okay, all right. Hopefully everybody can present. As I said before, I can help you. When you're in class, present. I can help you. You can get credits. Great. Okay, let me make you guys presenters. So we have a homework 16, 17, homework 14. Anna, we're not going to present homework 14, right? Let's try to present homework 16, 17. So to remind us the new things. Then maybe we go back to review 14. All right, let's start with, maybe we start with Lola, homework 16, 66. Then Juliana, homework 16, 65. Then homework 17, Samir.
Professor?
17. Yes.
The list started on top. Jeremy was the first one.
Oh, Jeremy, I didn't see
that time he wasn't here, so I understand that's why you missed that chart.
Oh, okay. Thank you very much.
But he was first, and then I was next.
Okay. Anybody else I'm missing? So Jeremy. Okay. Thank you. Hopefully everybody can present something. Okay, James, Kevin, Liam. Let me make you guys all presenters. All right. Sarah. All right. Let's go.
Hello?
Yeah, Jeremy, are going first. Who's going first?
Hello?
Yeah.
Jeremy.
Yeah, Jeremy. Okay, which one you are presenting?
Okay, so it's my turn, right?
Yeah, you can go.
Okay. This question's 1 and 2.
From homework, which homework?
17.
Homework 17. 1 to 2 is a conceptual question, right?
Yes.
Yes, possible you can present another one instead of 1 and 2. 1 and 2 basically is just conceptual. You fill in the blanks, right?
Yeah. So do I choose another one?
Right. Choose another one, please. I'm trying to see what's 1 and 2. Homework 17, 1 to 7.
All right.
Yeah, let's not show 1 and 2. Let's show the calculation ones.
So I'll do 4.
Okay, thank you. 4 is f of x equals to 3 plus sine x, right? We want to graph the function.
Yes.
Okay.
Yeah, this is my work. This is my table. I got the amplitude period to pi phase width shift, which is 0 to the vertical shift is 3 to the right. Yeah, that's basically what I did.
Let me ask you some questions. Okay, let's go over all together, right? Okay. Well, even a trig function. This function is f of x equals to 3 plus sine x.
Yeah.
We want to graph this function probably based on the basic function f of sine x. Okay, and we know sine x function, right? I cannot draw on your. Okay, let me ask you one question. How do you know your amplitude is 3, right? Or
Yes.
1? Okay, it's 3, right?
Yes.
Oh, no, it's 1.
Yes.
It's difficult for me to see it.
Yeah.
Let me make it bigger. Okay, it's 1. Can you tell us why the amplitude of this function is 1?
I guess first, actually, to be honest.
No, it's from somewhere, right?
Yeah.
It's from the
right.
number before sine x. What's the number before sine x?
Is it 1?
It's 1, because
Yeah.
no number is that. By default, that's 1. That's why your amplitude is 1.
Okay, so it's like so is it kind of like with the log, how the default could be 10? So the default is 1 if there's nothing before the sine x?
But nothing before the sine x is just 1. 1 times sine x is 1. It's the sine x.
Okay.
So 1. So the second question is why period is 2 pi? Let me write in the chat.
Because that's...
Let's write the function in the chat. So f of x equals to, the book use a sine parenthesis. Book use b, right? Or use k, kx.
Yeah.
I type in the chat. The book use a sine of kx. So the amplitude is the a. Is the number before sine. And what about period? Period is 2 pi divided by absolute value of k, right?
Yeah.
In this case, what's k?
What's k?
Yeah. What's the number before x?
It's 1.
It's 1, right?
Okay.
So 2 pi divided by 1, that's why you get 2 pi.
Oh, okay. So is it like adding?
No,
Adding
it's
the
not.
ones?
Let me share my screen. Let's go back to review the question, review the function. It's very important to know the function of trig functions. But those are the basics for you to get into calculus class. Okay, look at this. Jeremy, can you see the screen?
Yes.
You see this one? Y is f of x. F of x equals to a times the sine of k of x minus b. Or we can write this as, different books read a little bit differently. F of x may be read as a, usually book use a big capital letter A. Sine of kx minus kb, right? I just distribute the. This is still same as this one, right?
Okay. Yeah.
Or let's read this. So if written in this says have amplitude absolute value of A. Because this A can be negative. Let's use the example. Let's see, we have this f of x equals to maybe 3 minus 2 sine of 3x minus 4. I'm just giving an example. Let's compare with this. Oh, this one doesn't really have this 3. Let me erase this 3 first. So let's see the second one. What is A in the second one? A equals to,
Is it 1?
equals to 2. We need to figure out A, figure out K, right? Because the amplitude is the absolute value of A, and period is 2 pi divided by K.
Okay, okay.
Okay, well, absolute value of K, because this K can be negative also. So A equals -2, right?
Yeah.
The amplitude is 2. And K is equals to 3, right?
Right. Yeah.
So then what's period? The amplitude is 2, and the period
Isn't it like -2?
is 2 pi divided by K. Well, K in our case is 3. So
The amplitude is not -2?
I'm sorry. Oh no, the amplitude you see here, you see in the inside the box. You
Yeah.
see the absolute value of A.
Okay. Oh, okay. That's
It's the absolute
right.
value of A.
There's 2.
The period is 2 pi divided by absolute value of K. Because here we limit the K be positive, but the K of course can be negative also.
Okay, okay.
So period is 2 pi divided by absolute value of K. So that's why we have 2 pi divided by 3. Okay, now let's go back to your homework. Oh, can you share your screen again?
Yeah, sure.
Now you see the number before. So A in this case is 1. So your amplitude is 1.
Right.
And K in this case is 1. So your period is 2 pi divided by 1 is 2 pi. And then you said, lastly, you said, okay, the phase shift is 0. We don't have a phase shift because the x value is not changing. And the vertical shift is 3 units up, exactly.
Yeah.
Yeah. So sometimes it's easier to draw a line here. Maybe probably you don't see my point. Draw y equals to 3 line, horizontal line. It's easier for you to draw the graph.
Yeah. So
Okay.
is it like as long as I just like draw the line to show the graph, would it be okay?
Let me just show you. Let me just share with you. Okay, we want to draw the graph. So let's draw this one. So I have f of x equals to 3 plus sine x. It's always good to draw the reference graph first. The reference graph, which is sine x. Right? As I said before, we need 5 points. Because sine x, let's call g of x. G of x. We take as reference graph. And then f is just transformation. F is a transformation of the g. So how do we draw sine x? We use 5 points. We use 0. So this is 0. And we use pi over 2. This is pi over 2. So this one, pi over 2. And the next one is pi. And this one 3 pi over 2. Last one 2 pi. Right? Because with 2 pi, the period of this is 2 pi. The amplitude is 1. So amplitude is 1 means the highest point of sine is 1. The lowest point of sine is -1. Sine 0 equals 0. So we have this point. Sine pi over 2 equals to 1. Sine pi equals to 0. Sine 3 pi over 2 equals to -1. Sine 2 pi equals to 0. So we call this a 5-point. 5-point method. So how do we draw it? You know, we draw it like a curvy, kind of like a circle kind. So this is the graph of sine. Now we want to draw f of x equals to 3 plus sine x. So comparing those two. So f just pushed g 3 units up. Transformation. Remember we talked about transformation before?
Yeah.
So this is 1, this is a 2, this is a 3. So this is a 3. And 0 now becomes where? 0 plus 3. So this is 0. Oh, this should be 4. I'm sorry. I like to make 4 because I have to reach this point. 1 becomes 4. So this is a 3. It's not going to be very nice picture. Let's see, 2 is somewhere. Let's make it more actually. So this is a 2. This is a 3. Let's just make it one more. So this is a 4. Okay. Before we have a 0, 0. Now that point becomes 0, 3. 1, 2, 3. Make sense?
Yes.
And before the point was pi over 2, 1. Right? This is pi over 2, 1. Now becomes pi over 2, 4.
Okay.
Before was pi, 0. Now becomes pi, 3. So that's why I said, you know, maybe we draw a line, y equals 3 line. So this is y equals to 3, right? It's like we push x-axis up 3 units. So we push these 5 points, 3 units. So this push up 3 units, this push up 3 units, this push up 3 units, this push up 3 units somewhere here. This push up 3 units. Now your f of x is this graph. Okay, does this make sense? We only need to draw one period. But sine, cosine functions are periodic. We only need to draw one period. Does this make sense? Well, anybody has any question?
So is it like when I'm doing the homework, do I show a reference graph first?
Oh, reference graph is for you, right? It's for you to use it. But if you think you don't need it, right? You could use the table value.
Ms. Chen, I'm gonna have to leave because like
Okay.
I do have accounting class like right now. So yeah, I'll just see you later.
Oh, sure, Liam. Let me. So when do you like to talk? Oops. Okay. Anyway.
So is that it for me?
No, that question was for Liam. He said he has to leave, but also he needs to talk to me.
No,
also,
Nothing for like the presentation.
Oh, the presentation, right? The presentation, right? Okay,
Yes.
right. Okay.
So
So,
am I
do you
done?
want to try another one? Do you understand what's going on now? You know, how do we find the amplitude? How do we find the period?
Yeah. I mean,
Okay.
I can just keep trying, you know.
Okay. Well, you want to try another one? Or you know what? Let Rina show. All right. If you have questions, ask. All right. Thank you. Thank you,
Sure.
Jeremy.
Thank-
Thank you. Okay, Rina.
So I'm doing 29 for y equals cosine x minus pi over 2. I had to find the amplitude. It's 1 because there's nothing in front of cosine, so it's just 1. And then for the period, it's there is nothing in front of the parentheses, like in between cosine and parentheses, so it's basically just 1. So according to the formula, it's pi over 1, which is just, 2 pi over 1, so it's just 2 pi, the period. For the phase shift, inside the formula, it's just b, but I could also just solve for x minus pi over 2 and end up with pi over 2. And then I had to sketch the graph. So since the phase shift was pi over 2, I start the first period from pi over 2, like the starting point. And then I had to find out what the ending point was for the period. So for pi over 2, I added 2 pi, and then that ended up with 5 pi over 2. So that's the ending for a whole 2 period. And then that's what the graph looks like. The only thing I didn't know is what the middle number would be, because I don't know how to find the middle number and the other number here and here.
The middle number we can find subtracting those 2 points, 5 pi over 2, subtract pi over 2, then divide by 2.
Oh,
5 pi over 2, subtract pi over 2 will give us 4 pi over 2, which is 2 pi. So 2 pi divided by 2, so this pi. So this middle one should be pi.
oh, can you please write that down?
Okay. Find the middle point, we always do the end point, which is 5 pi over 2, subtract the initial point, which is pi over 2. And when we do that, we get a 4 pi over 2, which equals to 2 pi. Then we divide 2 pi by 2 because we want to find the middle point. Middle point means we have same distance to the initial point and to the end point. So 2 pi over 2, we get this pi. So the middle point is pi. Then you do pi minus pi over 2, which is the phase shift. Okay, is this okay? The middle point.
So you're saying that after pi over 2, it's going to be pi, and then for pi over 2.
Right, let's draw over here. So your function is f of x equals to cosine of x minus pi over 2, right?
Yeah,
Okay, so that's your function.
yes.
Basically, basically we have a cosine function. So let's draw that. Let's mark the 5 points. So I have 0, I have pi over 2, I have pi, I have 3 pi over 2, I have 2 pi. We always end up with 2 pi. So for sine and cosine, we use from 0 to 2 pi. So this is pi over 2. This one is pi. And this one is 3 pi over 2. Okay, and the graph, I'll draw the cosine graph first. So this is a 1. This is negative. So cosine 0, right? Use 0. I use this 5 point to draw sine and cosine. Now I'm drawing cosine. Before I draw sine. So cosine 0 is 1, right? So I have this point. Then cosine pi over 2 is 0, right? Then cosine pi is negative 1. Cosine 3 pi over 2 is 0. Cosine 2 pi is 1. So the graph looks like this. Goes from here to here. Then it reaches this negative 1. Not straight lines. Goes like this. Like this. Right? So this is a cosine graph. Let's call it G. G of x equals to cosine x. So this is one period of cosine graph. Well, let's see now. Let's see this one. You already figured out the amplitude is still 1, doesn't change because the number before cosine is 1. And the period is still 2 pi because the number before x is also 1. So the amplitude is still 1. The period is still 2 pi. Only we have horizontal shift because we see x value is changed, right? Cosine x before now become cosine of x minus pi over 2. Minus indicates horizontal shifting to the right. So that means this 0 value, x value, being shifted to here. Or we can think the y-axis being shifted here. Then we just need one more point, right? So the graph is being shifted. So this point is being shifted here. And this point being shifted. This point is being shifted here. I'm using red color. And this point is being shifted here. Every x value of the point being shifted pi over 2 units. And this point being shifted here. And this point being shifted here. Horizontal shifting. Horizontal shifting. So this is different from, we could see from different from Jeremy's graph. Jeremy's graph is, let me write here. Jeremy's f of x equals to sine x plus 3. Or we can write 3 plus sine x, right? Similarly, we see this is a horizontal shifting because every y value being pushed up 3 units. So y value being changed. But here we see the x value being changed, the angle being changed. The angle being changed. So this is a vertical shifting. This is a horizontal shifting. That's why we see Jeremy's graph is pushing every y value 3 units up. But right now your graph is pushing every x value pi over 2 units. Anyone has any questions?
I still have a question.
Yeah.
So like on the missing points that I didn't write in between pi over 2 and 5 pi over 2, is that pi and then 2 pi? I don't know what you wrote. I can't really see the number anymore.
3 pi over 2.
Oh, 3 pi over 2 and then 2 pi.
Oh, you were talking about this point, right? Yeah, this is the middle one. This is the point, the middle point, 3 pi over 2.
Oh yeah, the middle point. Because then you told me it was 4 pi over 2. In the
Right, because this is not 5 pi over 2. Oh, this is, oh, okay. Let's see, what did I do wrong? What did I do wrong? So this one is 2 pi plus pi over 2, which is 5 pi over 2. So what I did is 5 pi over 2 minus pi over 2. That's 4 pi over 2, right? 4 pi over 2, which is 2. Oh, no. Okay, we need to add those 2 points. I did a subtraction. But I did it wrong. So we should do 5 pi over 2, 5 pi over 2 plus pi over 2, which equals to 6 pi over 2. Then we want to divide this one by 2 because we want to find the middle point. Middle point is add the 2 values, then divide by 2. I did a subtraction. So 6 pi over 2, which is 3 pi. Then 3 pi divided by 2 is the middle point.
So
Right.
it's not 4 pi.
It's not subtraction. When we find the middle point of 2 points, we add the 2 values, we divide by 2. Because it's find the average. Find the average.
Okay, and then
Right. It's adding subtraction, right? I did a subtraction before.
so since that's 3 pi over 2, and then for the middle in between pi over 2 and 3 pi over 2, you add again and then divide by 2.
That's right. So we add pi over 2 plus 3 pi over 2, which is 4 pi over 2. Then we divide by 2, we get a pi.
Okay, and then the same thing for 3 pi over 2 plus 5 pi over 2. And
we get 8 pi over 2, then we divide by 2, we get 2 pi.
okay, thank you.
You're welcome. Or if we already figure out this is horizontal shifting, pi over 2 to the right, just shift the points. So shift 0 to pi over 2, shift pi over 2 to pi, shift the pi to 3 pi over 2, shift 3 pi over 2 to 2 pi, shift 2 pi to 5 pi over 2. Okay.
Okay, thank you.
You're welcome. Anybody has any questions? All right, let's see more presentations. So next one. Okay, who's ready? Samir, are you ready to present?
Yeah, I'm ready.
Okay, let me do this. This part of material is the most difficult ones, I think, among all those questions. Graphing trig functions. Okay, Tijeta, you want to go after Samir?
Can I go now? Good?
Yeah, go ahead.
Okay, so for this question, we have to find the amplitude and the period of the function. Then I have to sketch the graph of for this function that we have is y equals cosine 2 of x. So the first thing I did was I identified the amplitude, and it was a 1 because there was no number here, so I assumed there was 1 right away. And to find the period, I just divided 2 pi over 2, ended up with pi. And here I wrote the example down on the graph. So here I showed where the amplitude was on the vertical line, where the period solution was on the horizontal line. And we know that this is a cosine curve line because it starts at the maximum point of the amplitude and then it goes straight down to the minimum value, and then it just repeats that same process along the x-axis.
Okay,
And
I see.
That's how you get the solution. Yeah.
Okay, what I need is let's try to figure out the points in the middle, like
Okay.
a So I have this. So this finished 1 period to pi. From 0 to pi, finish 1 period. Perfect. Next time you only have to draw 1 period.
Okay.
Okay, let's figure out this. So this is the 0 point. Let's figure out this middle point. The middle point should be easy, right? Because from 0 to pi, the middle point should be
2, isn't it 2 pi over 3 or
2 pi over 4. What is pi
4?
over 2, right?
Yeah.
Because if we use the method 0 plus pi divided by 2, so this one is pi over 2. Okay, now from 0 to pi over 2, the middle point here is 0 plus pi over 2 divided by 2, which is
0 divided by 2.
0 plus pi over 2, which is
Oh.
pi over 2. Pi over 2 divided by 2
Pi.
divided by 2. Pi over 4, right?
Yeah.
So you figure out this one. You figure out this point.
So the point that's above pi. So we have
Right here. So far we have 0. We want to talk about the angles. We have 0, we have pi over 4, we have pi over 2, and then this one, we have this one, last one is pi. And what about this point? The angle of this point.
which one?
So
The pi over 2? 2
let me use
2 pi?
red color. This one, let me use red color. Can you see this red color?
Yeah, I see it now.
Yeah, let's just try to figure out this point. Then you are done.
So it's 2 pi over 4?
2 pi over 4. 2 pi over 4 still pi over 2, right? That's the point. But this point is between pi over 2 and pi.
Yeah.
This one should be 3 pi over 4.
3 pi over 4?
Right.
Isn't that's the one on the x-axis, right? That's what the red point?
Right.
Okay.
Right. On the angle, right? This is the angle, the x value. You see pi over 2 plus pi divided by 2, right? Pi we can write as 2 pi over 2.
Mm-hmm.
Pi over 2, get 3 pi over 2. Then we divide it by 2, get 3 pi over 4.
Okay.
So when we graph, we only need to graph one period with this 5 point. With this 5 point. Well, on this x-axis, we know the y value is 0. Right? And this one here, we mark 1, so we know this is 0, comma 1. Then here, this is pi over 4, comma 0. Pi over 2, comma negative 1. 3 pi over 4, comma 0. Then the last point is pi, comma 1.
1.
So we need these 5 points on the graph.
Okay.
Make sense? Okay.
Yeah.
All right.
Thank you.
Thank you. All right, next one. I think it's Tijeda, right? Tijeda wants to go after Samir.
Yes.
Okay.
Okay. So we're presenting question 55 from homework 16.
Okay.
Okay. Okay. So the first one I got is sine and the cosine, and then it's telling me to find, like, it has if it can be in quadrant number 2. So I use the Pythagorean identity, which is sine squared t plus cos squared t is equal to 1.
Sorry, Tijeda, which one? Which number?
Sorry, give me a second. Number 55, the first one.
Oh, 55. 55.
55. Yeah.
55. I think we already presented this one, no?
No, nobody presented that today.
Okay, not today, but before, last class.
I didn't present last class. I wasn't here, so I'm not sure.
Yeah. Anyway, go ahead.
Okay. So as I was saying, I use the Pythagorean identity. Where sine squared t plus cos squared t is equal to 1. So I removed the cos squared t to the right side by subtracting. And then I got left with sine squared t is equal to 1 minus cos squared t. I forgot to put that step, but I just said it right now. And then to get rid of the square from the sine squared t, I square root on both sides. And I got sine t is equal to plus or minus square root of 1 minus cos squared t. But since they say specifically in quadrant 2, I came to a realization that all values of sine in square 2 in quadrant 2 are all positive. So that's why I put sine t is equal to square root of 1 minus cos squared t.
Right. Sine is positive in the second quadrant.
Yes.
Okay. All right. Do you like to show how to graph sine function?
No, I don't know how to do that.
Oh, okay. All right. Maybe try next class.
Yeah. Thank you.
You're welcome. Okay, so Lola, I'm trying to follow the chat. Lola, Kevin, Julianne, then James.
I'm ready. I'm gonna share now.
Okay.
1 second, please. Homework 60. Oops. 1 second. I'm trying to find number. 66. Page 132. Is that it? Yep. Can you say it? No.
Yeah, I can see.
Okay.
Go ahead.
All right. So I'm going to be presenting number 66. Question says so the question says cosine t equals -4/5. With terminal point of t in the third quadrant. Wait, did I present this? No. Okay. So first thing first, we're gonna put in mind that so according to the question, the terminal point of t is in the third quadrant, and we know that cosine t equals -4/5. So we're going to start with the equation of the unit of circle, which is x squared plus y squared equals 1. So from this, from the question, we know that x is equal -4.
Oh, Lola, hold on, Lola. You sent me your presentation already about this already. Did you?
Was it this question? I thought it was the other question.
No, it's about this x squared plus y squared, I think.
So I can do like from this homework.
No. But you have to do different ones, right?
It's not the same question.
I know, but from each homework, I'm trying to see if that's the same. But for the similar type, this is homework 14.
Wait, actually, I think I have to present number 60. So can
Right,
I
try to do different ones. Yeah. Oh, hold on a second. Yeah, that's right. I think it's here. Then let me see yours. Oh, maybe different. Maybe different.
It's different questions. It's not
different. It's different. Right. All right.
It's just
Yeah,
like
go
similar.
ahead. Go ahead.
So 66. Wait, I got confused. So present the other one I was presenting. Go ahead with the other one.
No, go. Yeah. Preferably, you can show something different because 65. You did 65 when in the presentation, and this one is very similar to that one, right?
Yeah.
Yeah. So can you show different ones, different type?
Okay, let someone else go. I'm gonna go after the next person then.
Okay. All right. Thank you, Lola.
Which one? Yeah.
Okay, Kevin.
Yeah.
Okay.
I can share mine.
Hang on. It's this mic for a second.
Okay, I'm gonna be doing homework 16 on question 70.
Okay.
So the question was SECT equals to 2 sin t less than 0. So what is okay, my fault. So cos t equals 1/2, and the terminal point by t is basically p open parentheses.
hold on a second, Kevin. You're doing this secant t equals to 2, right?
What happened?
Secant t equals to 2.
Well, yeah.
Then what's cosine t?
The cosine t?
Right.
Oh, wait.
Because you were saying cosine t equals to 2.
Oh, my fault. Never mind. Oh,
No, what you wrote is right.
yeah.
But if secant t equals to 2, what's cosine t? Remember the secant t
The
and cosine
cosine thing is 1/2.
exactly. Because cosine equals to 1 over secant. Well, secant t equals to 1 over cosine.
Yeah.
Okay, go ahead.
Okay, so what was it? Open parenthesis was 1/2, close parentheses to the square, plus y to the second equals 1. So
Okay, Kevin, I know I can't read what you wrote there. Explain to us what's going on here. Why you're writing half square plus y square equals 1?
oh snap. I'm sorry, my freaking head is everywhere. I basically wrote it like this because, and hold on. I gotta look at the question.
The question is, okay, let me remember. Let me use the whiteboard. Okay. Let me use the whiteboard. Your answer is right, but I need you to show me you understand why is that. So let me write for you. So secant t equals to 2. And what's the second condition?
What happened?
The first one is secant t equals to 2. What is the
Yeah,
second?
it was sin t less than 0.
Sin t less than 0. Okay, can you see on the screen?
Yeah.
Okay, so this is the question. What do we need to know? What do we have to do? What's our goal here? We have to find other.
What to find other
So given this, we need to find other values of trig functions of t, right?
Yeah.
Let's say find the sine t. Let's find all of them: cosine t and tangent t. Okay. So you were saying your first step is right. You said, okay, if secant t equals 2, cosine t equals to
The cosine t was a 1/2.
1 over 2. Great. Okay, we have this. Now, cosine t now you are using x squared plus y squared equals to 1.
Yeah.
Even better, let's use this one. Sine squared. Do you remember what's sine squared t plus cosine squared t?
It's nice. Wait, say that one more time.
Sine squared plus cosine squared. I wrote on the board already.
Yeah.
Sine squared t plus cosine squared t equals 1. You wrote as x squared plus y squared equals 1, as you are thinking the point on the unit circle. But let's use this one. Let's use sine squared plus cosine squared equals 1.
Yeah.
Okay, now you go from here. I'll write for you.
Okay, so what I did right there after that was I did y equals to plus and minus to square root of 1, 1 to negative 1
We
over
don't
4.
need to use y, right? We don't need to use x and y.
Wait, no. Oh.
Right, we have cosine. We can use this equation to solve for sine, right? How can we use this? You see, we're given this. We're given cosine t equals to half. So we know this one. We need to solve for sine.
So for sine, okay, so then for sine it would be
So can we just plug in? So we don't know sine, right?
No.
Keep sine square t. Now we know cosine. Cosine equals to half.
Mm.
Change cosine t equals to half. So cosine square t equals to half square. Right?
Yeah.
Solve for sine t, because our goal, one of our goal is to try to solve for sine t. Sine t.
For sine t, for t, I knew that it was in quadrant 4.
Well, let's think about quadrant 4 later. So now, so we're working with the equation sine squared plus cosine squared equals 1.
Mm-hmm.
So we know cosine, so substitute cosine into half square. So let's solve for sine t. How do we solve for sine square t?
So you minus f from both sides. No, first you solve the f to the power of 2.
Right, let Kevin try. Kevin, can you tell me what's half square? What's half times half?
Isn't it 1?
Half times half, not adding them.
Is it half times half?
Right, with multiplication, right? We have, so half square, right? Because we need to calculate half square.
So isn't it
Half,
0.25?
yeah, you can use calculator, right? But let's try not to use calculator. Half square means half times half. What's half times half?
Half times half is, wasn't it 25? That's right.
How do we multiply those two fractions?
Wouldn't you do 1 and 1? No.
1 times 1, what do we get?
1.
1. 2 times 2.
4.
So do you see half square is 1/4?
Yeah.
Okay, so we get, so this term is 1/4, right? So now let's subtract 1/4 on both sides. So we get sine squared t equals 1 minus 1/4. So what is 1 minus 1/4?
1 minus 1/4.
Right?
I put that in here. Let me see.
Let's try not to use calculator because we need to find the exact value. We need to use fractions.
Mm-hmm.
So how do we do 1 minus, let's do on the side, 1 minus 1/4. How do we subtract those two numbers?
So it will be point.
Let's try,
Wait, 0.4.
I'm sorry?
0.4.
Okay, so to subtract those two numbers, we need a common denominator, right?
Mm-hmm.
So we need 1 to have a denominator of 4. So that means we want to write 1 as 4 divided by 4. Does that make sense?
Yeah, a little.
Because 1 is always some number divided by itself.
Mm-hmm.
1 equals to 2 divided by 2, 3 divided by 3, so on and so forth. When we subtract those two numbers, right, we would need a common denominator. So we change 1 to be 4/4. 4 apples shared by 4 people, so each one gets 1 apple.
Mm,
Does this make sense at all?
yeah, a little, but yeah.
Because when we subtract numbers with fractions, we need to have a fraction with a common denominator, right?
Uh-huh.
Okay, so now what do? We have 4/4 minus 1/4. What do we get?
So isn't it through? Isn't it 3?
3 over?
Isn't it 3/4? Yeah, 3/4.
3/4, right? So once we have a common denominator, we keep the common denominator. We perform this operation with with the numerator. So 4 minus 1, that's 3. So 3 over 4. So think
Mhm.
about it. You have one whole pizza. You cut into 4 pieces. Someone take one slice away, one piece away. How many slices you have? You're left with 3/4, right?
Yeah.
Okay, now makes sense?
Yeah.
Okay. So now sine square equals to 3/4.
Yeah. Sine squared equals to 3/4. Yeah.
Sine square of t equals to 3/4. How do we go from there to solve for sine t? Because now we have sine square, but we need to find the sine. Because our goal is to find sine t. Can you try to find sine t?
Wouldn't you put the square root?
Yeah, so we square root, right? So we
Uh,
get a sine of t equals to, when we square root, what happens? We got a plus minus 2 values, right?
Yeah.
Let me put a slash in the middle. So we'll get a square root of 3 over 4. Can we simplify this value a little bit?
Yeah.
We don't know square root of 3, so we keep it. Keep exactly. That's why we don't want to use calculator. If we use calculator give us 1 point something. We don't want to use that. So get a square root of 3. What is the square root of 4?
Square root of 4, 2.
True. Right? So sine t equals to plus or minus equal to positive square root of 3 over 2 or negative square root 2 over 3. Then let's go back. So we have this second condition, right? We have those two conditions. So we have used the secant t equals 2. We have used this condition. Now let's come to second condition. Second condition is saying sine t less than 0. This piece of information gives us what?
It gives a
We have 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant.
yeah.
So sine value be negative in which 2 quadrants?
4.
4 and
Is it 4 and 3? No, 4.
4 and 3.
4 and 3. Okay.
Try to remember all students take calculus. All right, what does it mean? In first quadrant, every trig function value is positive. Students in the second quadrant means only sine and its inverse cosecant being positive.
Yeah.
Take third quadrant, t means tangent and cotangent being positive. All others are negative. Fourth quadrant, only cosine and secant being positive. All others are negative. So now we have sine being negative in the third quadrant, in the fourth quadrant. Right? So we are given. So which value we should take?
The fourth quadrant.
Which?
Oh, which? You say which value?
It's a sine is negative, right?
Yeah. So it would be negative.
The negative value. Okay, good. All right. So we have sine t equals a negative square root 3 over 2. Okay, finish that. Cosine t you already know. Cosine t equals a half. Okay, can you finish tangent t?
The tangent t?
Right.
So the tangent t, it will be negative square root of 3.
Tangent t equals to y.
Yeah.
Okay, tangent t equals to sine t over cosine t. Try to use this relation. Tangent t equals to sine divided by cosine.
So
what is the sine? Sine is a negative square root of 3.
yeah, so negative.
Then
Yeah, so
divided by
negative 3 over 2. Yeah.
Divided by half, right? So tangent t equals to sine. Sine is negative square root of 3 over 2. Divided by cosine t. Cosine t is half. Now, can you simplify this? Can you simplify tangent?
Simplify.
How do we divide negative square root of 3 over 2 by half? We change division into multiplication, right?
Mm-hmm.
Then we flip the second one. So half, when we take it as the inverse, it becomes 2 over 1.
2 over 1. So then wouldn't it, wait. Wouldn't it also be like 2 over 3 as well, or no?
What do you mean 2 over 3?
No way, I think I mixed it up. Oh, no, never mind.
Let's see if this makes sense. So tangent equals sine over cosine. Sine divided by cosine. So
Mm-hmm.
sine is this, negative square root of 3 over 2. Cosine is a half, right? So we use this one divided by this one. Now, how do we do division? Division, we can change it to be multiplication. So negative square root of 3 over 2 multiplied by its inverse of a half, which is 2 divided by 1, which is just 2. This is how we divided fractions, right?
Mm-hmm.
Okay, now what do we get? So tangent t equals to?
So tangent t equals to, the way how I have it is, where is it? Oh, it's, for
No, I
me,
don't want to read from your right what you wrote. I don't know who wrote for you.
no.
Who read from there?
Nah,
Because
for this,
when you explain,
I have my cousin help me. She know
when
how
you
to.
that's exactly I need students to present to me because I need you to understand. Doesn't matter who help you do the homework. It does not matter. But you have to understand how to do the question. Do I make sense? Once you can do yourself, you learned. You see this becomes negative square root of 3 over 2? Is the same as your answer?
Yeah.
Negative square root of 3 over 2. All right, Kevin, you have to go steps by steps. Ask your cousin, help you to understand the material, okay?
Okay.
Not only do the material. Presentation is not about reading. I don't want you to read. I want you to explain to me what's going on. All right?
Got it.
Okay. Thank you, Kevin. But good try, okay?
All right.
Let's keep trying. All right, who's next? I think Juliana.
Yeah, I'm next.
Okay.
So I was gonna present 65, but I guess I can't. So I'm gonna
From which homework?
Wait, am I gonna present you next? Damn.
you can go if you want, it's okay.
You can go on. It's alright.
Okay. I put in the chat that I was gonna present homework 16 question 65, but then you said somebody presented that. I didn't see anybody present that, but it's okay. I'm gonna present questions 68.
Okay, great.
All right. Can you see?
Yeah.
All right. So it said that tangent t is equal to 1/4, and the terminal point of t is on quadrant 3. So with the given information, I know that tangent t equals to opposite over adjacent. So then I plugged it in into the Pythagorean theorem equation, and I knew that hypotenuse equals radical opposite squared plus adjacent squared. So I plugged the numbers in, and because it's on quadrant 3, I knew that both of the numbers were going to be negative. So then I simplified the radical and I got radical 17, which that's the hypotenuse. So then for each trig value, I put sine is equal to opposite hypotenuse. So that's -1 over radical 17. And then that gave me negative radical 17 over 17. Then for cosine, I knew that it's adjacent over hypotenuse. So I put -4 over radical 17, which gave me -4 radical 17 over 17. For the next one, it's adjacent over hypotenuse, so that I put -4 over -1, which gave me 4. Next one, it's hypotenuse over adjacent, which gave me negative radical 17 over 4. And then last one, it's hypotenuse over opposite, which gave me radical 17 over -1. And then I simplified that to negative radical 17.
Okay, great. And Juliana, you see the picture I draw here?
Yes, I do.
Okay. So I think, so basically you are giving us a writing picture, but it's better to picture like this, right? It's in third
Okay.
quadrant. In third quadrant is what you see a triangle like this.
Mm-hmm.
Then the T is the reference angle. So this is the angle T.
Okay.
You said exactly tangent T equals, because in the third quadrant, so tangent T equals opposite over adjacent. So both be negative. Third quadrant, both
Yes.
x value, both y value be negative. So that's why we can make this opposite side. So here, -1, this is -1. And then adjacent side is this x value, which is -4. Now you can use these three sides. Now you, like perfectly, you use a hypotenuse, you use Pythagorean theorem to say hypotenuse equals to square root of 2 legs square plus sum of the 2 legs square. Okay, so Kevin, do you see this is another method? So Julian is just showing another method finding the other trig values by doing so. So with Kevin's question is, right, it's also in the third quadrant, right? Right. Okay, great. Good job, Julian.
Thank you.
You're welcome. Okay, next one.
Lola.
Yeah, Lola.
So can I present number 55?
Yeah, let me see what's 55.
Oh my God. Okay.
55, we already have someone presented already.
55, so
Let me see your homework. Let me see.
16?
Oh, this is from homework 16, right? You also done homework 17, have you?
No.
Oh, no, not yet. I see. So 65. That's why you complain too many homework to do. Okay.
No, I did
Okay.
17 already. Like, but I'm not presenting homework 17.
Okay. All right.
So
Because you have presented one of this. You sent me videos already, remember?
for number 55, I only sent you video for 65, and you said don't do 66 because it's similar to it. And now I'm doing 55. It's not the same.
55 is not similar to it.
Okay, so do it. I don't know. I'm just doing another video and send you there.
Okay, go ahead, Lola. Do 55. Let's just review it.
Oh, okay. Thank you. Okay, so actually you're right. It's kind of similar. So I'm trying to zoom in. Okay. Oh, yeah. So number 55 says sine t, comma cosine t, and then quadrant in the second quadrant, right? And that just means like what we're trying to do is to find sine t. So we're gonna use the equation.
Oh, hold on 1 second, Lola. I think this question is to write the first one in terms of the second.
Oh, to write. So we're trying to write sine in terms of cosine.
That's right.
And the t is in quadrant, and is in the second quadrant. So to do that, we're gonna use the equation, but then we're gonna substitute x and y for sine and cosine. And how we know that, like we know that sine squared t plus cosine squared t is equal 1. So we're going to substitute that based on what we have from the question. So in the question, so we're going to substitute so that to find sine squared t to find sine t by itself, we're going to say like we're going to try to solve this equation sine squared t plus cosine squared t equals 1. So to do that, we put sine squared t equals 1 minus cosine squared t, which is basically like we minus cosine from both sides of the equation to leave sine squared t by itself. And so sine squared t equals 1 minus cosine squared t. And we have to find sine t, not sine squared t. And to do that, we're going to square both sides. And then when we square root both sides. So when we square both sides, square cancels square root on the left side, and we have sine t equals plus or minus the square root of 1 minus cosine squared t. And we know that sine t is positive in the second quadrant. So our final answer is going to be sine t equals the square root of 1 minus cosine squared t.
That's it. That's it. Okay, thank you, Lola. And James, you want to try 57 from 16?
Yeah, sure.
Okay.
Okay, so share. Can you see my screen, Professor?
Yeah.
Okay, so for number 57, it's like number 55. We're going to write tan in terms of sine. So the first thing we'll do is that we'll use the reciprocal identity property, which is tangent is equal to sine over cosine t. And now, by using the Pythagorean theorem, the cosine will become square root plus or minus square root of 1 minus sine squared of square t. And since it's asking in quadrant 4, and by using the what do you call this? All student takes calculus, we can say that tangent in quadrant 4 is negative. So the answer should be tangent t is equal to sine t over negative square root of 1 minus square root of t. There should be a negative sign here. I just forgot it.
Okay. Usually we don't put a negative sign in the bottom. We can put a negative sign up front.
Oh, okay.
Okay, great.
Okay, thank you, Professor. Oh yeah, Professor, before we move on,
Yeah.
I saw the email that you sent me regarding about my homework, not being credited since it says it contains essential conceptual errors.
Oh yeah, I like to show you. Stay, when we finish class, stay, okay?
Okay.
Okay, I'll talk to you. I'd like to show you.
Okay.
Okay, anybody else like to present? Okay, anyone has any questions? Okay.
I have a question.
Yeah, go ahead.
So since Thursday is Thanksgiving, when is homework 17 due?
Homework 17. Homework 17. Homework 17. When did I give to you?
Last Friday.
Right. Usually I give you 2 weeks to do it.
Okay.
Do you still have time? Okay. Any other questions? All right. Let me
I have
share
a
my screen with
question.
you. So go ahead.
So I know, like, to make up for like presentation for the presentation grade, do
Right.
I send in more like more presentations for the homework? Like, do I email it to you, or?
You could do that. Okay. You could so if you don't have like if you don't have time to show in the class, you can, but make sure you follow the instructions. So you need to show your face. You need to show, so I know it's you who are presenting.
Okay.
Then you need to choose different questions. Maybe from each homework, you choose one.
Okay.
All right. Try not to do the first one, second one. Okay. Try not to do the easy ones because I
No,
need you to
yeah.
show me you understand.
I plan on presenting from now on all the time, but
Okay.
there's only like what 3 homeworks left.
That's
So
right.
my presentation grade, like, there's no way to make up for what I missed, or it's
Right.
just
No. You still have. You still have. You just pick one from the previous one, right? But as I
okay.
said, don't pick the easy ones because they won't be able to. There won't be enough to show me you do understand the material.
Okay,
Because I
no
want to give
problem.
you full credits. You know, if you show me you understand the material, so choose one from each homework, then to show to record yourself, then to share the link with me, to put on the cloud, to share the link with me.
Okay.
Okay. All right. Any other questions?
Professor, I have a question.
Yeah.
So I submitted my homework 15. I attached a video of me explaining one of the questions because I wasn't able to attend the class that day. I don't know if you received it or not.
Which one? I'm not quite sure. Did I?
Homework 15.
Homework 15.
Yeah, I sent you the homework plus a video.
Let me see. Together, right? Together, homework 15.
Tigida, yes.
Together. If I didn't send you anything, that means I received. If I have problems
Okay.
with it, usually I send you something. Let me see.
Okay then.
Yes, I did. I received it.
All right. Thank you.
Yeah, you're welcome. Yeah, usually if I have problem to receive it, I will let you know. Okay, so because you know why I want to give you more homework, because I want to spread the credits. I don't want the homework to be so heavy. Also, 18 homework 18, I will left you with less homework. Okay, so homework 18. I mean less problems. I do agree. I left too many problems for you. So let's see. So this is chapter 5.3. With these questions, let's see. 27 with pi in it, right? Might be confusing. Okay, let's see. 24, 23 to 24. So 23, 24. Then 35, then 30, 33, 34, then 38. 1, 2, 3, 4, 5. Okay, I give you 6 questions. Let me just find one more. 42, 42, 40. Practice on graphing those functions, all right? So homework 18.
Professor, I have a question.
Yeah.
This homework is based on the previous class, right? That lecture?
Yes, yes. Actually,
I thought you already gave homework on that. Isn't that homework 17?
17 I give already.
That's same, but isn't that based on the same material?
Yeah, you're right. Based on the same similar material. But we didn't really talk about the horizontal shifting here. So horizontal shift, did we talk about? So look at the page. What's the page? 392. Talk about vertical shift, horizontal shift. So let's see from here, right here. All right. So the horizontal shift is this. It's a number B here. All right. Phase shift. And the vertical shift we know from transformation, right? Just adding a number to the sine or to the cosine. Okay, any other questions? What is homework 18 do? Homework due, obviously due in 2 weeks, okay? In 2 weeks, which means December 11th? Oh no, December 4th. No. What day today is? Today is 25th, right? December 9th. December 9th. Yeah, may not be, maybe, you know what? Let's make this maybe last homework, okay? Then the review sheet. I haven't given you a review sheet yet, right? Did I? No, okay. So let's make this 18 the last homework. Then, yeah, I'll give you a review sheet. Then you can focus on the review sheet. All right, so no more homework, but this is the last one. 18 is the last one. Okay, I realize I did give you too much homework, too much problems in each homework. So 17 is due, right, quickly, by this week, I think, this weekend. And all right, any other questions? If you want to talk to me in person, stay after, okay? Okay, anybody else have any question?